Number 48 says a quarterback takes the ball from the line of scrimmage, runs backward for 10 yards, then sideways parallel to the line of scrimmage for 15 yards. He then throws a 50-yard forward pass straight downfield perpendicular to the line of scrimmage. The receiver is tackled immediately. How far is the football displaced from its original position? So in football, the line of scrimmage is where the ball starts. It's denoted in yellow. Basically what happens is the quarterback starts at the line of scrimmage, runs backwards for 10 yards. You can draw that as a vector. Backwards for 10 yards. Then sideways parallel to the line of scrimmage. So and then throws a 50-yard forward pass straight downfield, perpendicular to the line of scrimmage. So straight downfield is this way, and it's perpendicular to the line of scrimmage, which is important. And this one is 50 yards. So then the receiver is tackled immediately. So the final position of the ball is where it is thrown to. So basically, how far is the football displaced from its original position? So this is the displacement vector of the football. The path it took for the football to reach its final position is a lot longer than its displacement, which makes sense because displacement, we don't care about the path. We just care about where we started and where we finished and the distance between those two places. So we have to translate our distance path here into our displacement. So this is going to be done through vector addition. So if we treat downfield as positive and to the right as positive, we're going to be able to translate all of these purple vectors into, we're going to be able to add them all up to get to our orange vector. So our orange vector here, which I'll call vector D, is just going to be the addition of all these little purple vectors. So D is going to be, so this first vector here that's labeled as 10, so it's 0 in the x direction. Right? If we keep our traditional coordinate system the way it is, we'll have 0 in the x direction and 10 in the negative y direction. So we'll have 0, negative 10. This next vector is 15, and that's pointed in the positive x direction. So we have 15 in the x, and we don't move any in the y because it says it's taken parallel to the line of scrimmage. So if we translate into like x and y, there's nothing in the y. Then it is thrown 50 yards downfield. So that has to do with the y direction, right? And it's in fact a positive y. So 0, 50. Because it says it's perpendicular to the line of scrimmage, that means it doesn't move in the x direction at all, so we have 0, 50. After all this junk, all we get is that D moved, right? The ball, in the end, it moved 15 in the x, because 0 plus 15 plus 0 is 15, and it moved negative 10 plus 0 plus 50, or 40 yards in the y direction. So this vector D here has a horizontal component of 15 and a vertical component of 40, which is roughly reflected by how we drew our picture, so that's good. The question is, how far is the football displaced? So what we care about is the length of the D vector, which, if you remember, is the magnitude of D. So basically, we have to take the magnitude of D, and we'll see here that this is a right triangle. So we're going to use the Pythagorean theorem to find the length of the vector d, or how far the football was displaced from its original position. And because we know the x and y components, this is going to become simpler to solve, where we just take the square roots of each and add them. Take the squares of each and add them, and then take the square root. So 15 squared plus 40 squared, and then you take the square root of all of that. So once you do that, you'll get that the displacement, the magnitude of the displacement is 42.7, or if you're rounding it, 43 yards. Okay, so these types of problems where we have to add vectors, it's super important that we draw everything out very clearly and label the key components, such as each vector as well as the displacement vector and its components.